Hello, welcome everyone to lecture number 18 of Fundamentals of Computing. This is on operating system. In this lecture, I am going to cover the various functions of an operating system, or you can say jobs of the operating system. So what are the various functions of an operating system? It's a processor management, memory management, file management, device management, security, and coordination between other software and users. So let's first start with the processor management. Before starting the process management, one should know what the process is, because process is assigned to the processor. Process is nothing but it is a program in execution. So what if we do in the processor management? It involves managing the CPU, or you can say the processor, including scheduling processes, determining which process gets to use the processor, and managing the execution of processes. So I already told a process is what? It is nothing but it's a program in execution. There may be number of a process that wants to be executed, or you can say number of programs that you want to execute. Once the CPU is assigned or processor is assigned to it, then that it becomes what? The process. That process needs what? Certain resources, means including your processor time, memory files, input output device to accomplish its task. These resources are either given to the process when it is created or allocated to it while it is running. That will be done by what? The operating system. How it can be done? So it means for that your operating system has to do something. So what are the activities that operating system performs for process management? These are: keep tracks of the processor and status of the process, allocate and deallocate CPU to processes, or rather you can say processor to the processes, process scheduling, process synchronization, inter-process communication, and deadlock handling. These all are the activities that will be done by the operating system for process management. So let's start with one by one. What is the process state? The process state, it may be new state, or it may be ready state, or it may be running state, or it may be terminated state. At the terminated means what? It has been stopped its execution, or it may be in the waiting state. So these are the various states. Once the process is created, then that is what that we called it. It is at the new state. When it is loaded into the memory for execution, then we call what? It is in the ready state. When the CPU has been assigned to it for the processing, then we call it as the running state. Means here the processor has been assigned to the process for its execution. So by scheduler, or this process will be taken from the ready state to the running state, means taken from the memory and assigned the processor to it for its execution. So it moves from the ready state to the running state. Meanwhile, it might be happen that a given process may need some input output, or it wait for some event. So it moves from the running state to the waiting state. Once the resources had been assigned to it, it will move back from the waiting state to the ready state. when the process is at the running state and if it stops its execution, then it moves through the terminated state. It means what? Here the process has completed its execution. So these are the various states of a process. The information, since in a system a number of processes will be there, so the information about the each process is stored in the process control block. What it is stored? It stores the process state, means this process is in which of the state? It is in the running state or in the waiting state or terminated state or at the new state. What is the process number? This is to use to identify the process in the system. Then the program counter that keeps record of the line number from where the process stops, so that after when it moves from running to waiting, and then again it will has to start from that instruction number only, so that is stored where in the program counter, where the process has been stopped and from which line it should start resuming its execution. Another one is the registers that has been used for storing the data by the given process. What are the memory limits of memory limits means what? The memory required by the given process for its execution. Then list of files that are required, open files, and so on, many more. So this type of information are stored in process control block. So whenever a process is it's about to execute, it moves from new to ready state, ready to running, when the processor has been assigned to it. Once it completes its execution, it moves to the terminated state. If it waits from some resources, then it moves from running to waiting, and then again moves to the ready state. And all the information about the process are stored where in the process control block. So I said there may be number of processes or number of jobs in the system that has to be executed by the given processor. So in that case, you have to decide which job is to be assigned to the processor for execution. It may be what job 1, job 2, or n number of jobs are there, but this can be executed only when the processor has been assigned to it. So it means what? These are in the ready queue, and once it is assigned to this processor, then it moves from ready state to the running state and start executing itself. So here the question comes, so many processes are about to execute. How we will manage it? So that can be done by the process scheduling. Why the process scheduling is required? Because you should have a optimal use of a CPU. That is, CPU never sits idle. Some process should be assigned to it. So to achieve the maximum utilization of a CPU, you have to do what? You have to use the various process scheduling algorithm, and these process scheduling algorithms are, it may be, you can use first come first serve, shortest job first, round robin, or you can have the priority scheduling. These are the various scheduling algorithms that ensures the maximum utilization of CPU. How to check which algorithm is to be preferred? That depends upon the some criteria. That is, you can say first one is throughput. Throughput means what? The number of processes that gets executed by the CPU at a given time. So for maximum utilization of this CPU, it should be maximum. Another one is turnaround time. Then you have a waiting time and response time. These are what? Throughput, I already said, the number of processes executed by the processor at a given time. For maximum utilization of CPU, it should be maximum. Turnaround time means the total time taken by the processor, given process to complete execution. So it should be minimum. Waiting time, how long the process waits for the CPU to get it assigned. So it should be minimum. Response time, when the process starts executing itself. So it should also be minimum. So for this, for better utilization, or you can say maximum CPU utilization, the throughput should be maximum, turnaround time, waiting time and response time should be minimum. So this was about how the processes has been allocated to the processor in a system for maximum utilization of CPU. Another task of the operating system is what? Inter-process communication. Inter-process communication means what? How the two processes communicate with each other. So for that, first you have to check the processes whether they are dependent or independent. Dependent means what? If they shares the same resources. Independent means what? P1 and P2 executes independently without sharing the resources. If P1, P2 shares the same resources for its execution, then it calls as a dependent processes. So problem comes when we deal with the dependent processes. So that can be done by the two methods. That once when we use a shared memory or by using the message passing technique. Shared memory meant both the P1 and P2 that shares the same memory or same data. So both of them should not enter into this memory location at the same time. That means what? There must be some synchronization between P1 and P2, because once the P1 enters into this memory and update the data over here, in that case the P2 has to wait over here. So this is also called as a critical section. Means this, if this is shared among P1 and P2, then at a given time only P1 enters into it and P2 has to wait. Once the P1 completes its execution, then P2 enters into this memory or the shared, or use the shared resources or use the shared data. Message passing means what? This is in the network. So if one of the computer is here and another one is here, so one process is executing over here that needs some data from the P2, then that has to be communicated to through M2 through message passing. So in this way, how the process management is done by the operating system. Last one is the deadlock. Since there are number of processes and there needs resources for its execution, so this is the condition if P1 is requesting for the resource R2 which is assigned to P2 and P2 is requesting for the resource which is assigned to the R2, this condition is deadlock. So operating system should take care of this deadlock should not occur. That will be through the deadlock avoidance, deadlock prevention. So there are many conditions that one can check in the how to prevent from the deadlock. And for avoidance, we use algorithms for a system to avoid a deadlock. Especially we use here the banker's algorithm to avoid the deadlock. So this is how the processes are managed by the operating system. Second one is memory management. Memory management is what? Anything that you want to execute in the computer that has to be loaded into the main memory first, or you can say RAM first, otherwise it is not execute. Since you have the number of jobs that you want to execute or number of processes or programs that you want to execute, and every program needs memory for its execution because that has to be loaded and that memory is same. So there must be some provision to manage this memory so that all the programs gets loaded into the memory and will execute itself. That is, for better utilization of a memory, we need a memory management which is done by the operating system. So what it does, the operating system allocates memory to running processes and manages the allocation and deallocation of memory space, plus ensuring efficient use of the system's memory. It means what are the activities that are performed by the operating system for memory management? These are, it keeps track of which parts of memory are currently being used and by whom. It decides which processes are to be loaded into memory, that is, assigns memory for execution, and how much is to be allocated. It allocates memory when needed by process for its execution. It deallocates memory assigned to process once it terminates or completes its execution, so that that memory can be available and used by the other processes for execution. So how it can be done? Okay. Here we have what? A memory. So this memory is divided into two parts. This part can be used by the user and this one is used by the operating system. Here the users cannot use this memory. It is reserved for operating system. Only this much area is there available for the user to use it. So how we can check which part of memory is available for the user? That is done by using two registers, that is the base register and the limit register. So if user 1 is there and wants to execute the process 1, then this much memory is available to it, and that is decided by what? Decided by the base register and the limit register. So for proper utilization of a memory, the hardware address protection with the base and limit address is there. Here what happens? CPU will generate address that we call as a logical address. Then it has to be checked with the base register whether it's greater than or less than. If it is greater than this, then it means what? There must be trap to the operating system, means you have to stop over there because you won't use this space. It means what? You are not in the memory which are available for the user. If it is yes, then again it will check with the base plus limit register. So it is what? Base plus limit register, to ensure that the address which is generated by the CPU is within the limit of the memory which is defined for the user's use. and this is what your main memory. So address that is generated by this will be a physical address that is mapped to the main memory. If it is no, then trapped to the operating system. So in this way, the logical address which is generated by the CPU is mapped to what your physical address of a main memory where the data is stored or from where the data is to be retrieved for performing some operations on it. So in this way, the hardware address protection with the base and limit register is done to ensure that only that much memory is used by the user which is available or which is defined for the user. Okay. Another important thing is what? The fragmentation. When we are using a memory, so it might happen that we are assigning a processes which needs a memory that is either less than the space which is available or it may be more than the space that is available. Say this is what the memory, and a processor P1 needs a space for its execution. So this much memory is assigned to it for its execution. Apart from this much space, the processor only uses this memory and this is left. So it means what? This is not used by the processor P1. Similarly, for the process P2, this much memory is assigned to it, in which only this part of memory is used and this is not used. Say here it is total of 50K and this is what this total is 60K. This process needs only 20K and this needs only 10K for its execution. So how much memory is left by this? 50 by this, and 50 minus 20 means this 30 is left by the space left out. Now we want to execute the process P3 which needs say 30K. So that can be assigned over to this much space, but this is already assigned to what? Assigned to the process P2. So if it is the case, then we say what? This is the internal fragmentation, means large memory is assigned to both the process P1 and P2, but they need a less memory for its execution. So that case is called as a internal fragmentation. In case of external fragmentation, what happens? This much space is assigned to process P1, it uses it. This one space is assigned to process P2. Now this much space is left behind, it is unused. Now the blocks that is available is, say this is 20K and this is 10K, and you want to execute a process P3 of 30K. You have a 20K and 30K over here, but you cannot execute P3 because it needs a 30K. This is scattered into 20 and 10K. If this is the case, then this is called as a external fragmentation. So operating system should take care of avoiding this internal and external fragmentation while allocating a memory to the different processes in the system. This is another example of internal fragmentation. It's what it says. Here we have two processes. One needs a 60 KB, another needs a 20 KB. And this memory is divided into equal parts, that is the 100 KB of each block. When the 60 KB is assigned, process P1 is assigned to here, it means what? 40 KB is left unused. When the 20 KB is assigned to this block, it means what? 80 KB is left unused. So this is the case of what? Your internal fragmentation. Although the P1 is assigned this 100K block, and P1 and P2 both of them are assigned a 100K block, but the P1 only needs a 60K for its execution, so 40 KB it's unused. In the case of a P2, it needs only 20 KB for its execution, so it means what, 80 KB is unused. So this should be avoided, and there are various algorithms to avoid this internal and external fragmentation, that are say paging and segmentation, that are used to avoid this internal and external fragmentation for better utilization of memory. Okay, so how this can be done in the memory management by the operating system. Another one is the virtual memory concept. Means here it is a technique that allows the execution of a processes that are not completely in the memory. It means what? It can execute a program that are larger than physical memory. How it can be done? So here we are using a technique that is called the paging, where the logically this memory is divided into number of pages, and its size is same as that the blocks in the physical memory. This is the backing storage, or you can say secondary storage. Here this is called as the page table. So this particular page is mapped into the page table, and see, if it is there, it means what? Then it is mapped to the physical memory. If it is present over here, it will execute itself. Suppose this page is not present in the page table, then what will happen? If it is present over here, then it will be taken to this space, and then mapping will be done accordingly. So it means what? If a process P1 that needs a page A, I mean this A, to execute, it should be loaded into the main memory, but it is not there in the physical memory. So what will happen? If it is full, one of the block is, this is freed, this will be taken to here. If it is, say, if it is B, this will be here, this whole will be free, so free space is available, and this will be, A will be allocated to this place. So in that way, although all the pages that are related to the given process P1 are not present in the physical memory, but they get executed in this way by taking it, moving it to from the backing storage to the main memory. This is the concept of a virtual memory. So there we have the different algorithms that are used to find this page fault. Page fault means what? When it is not pages which is not present in the memory. So it means what? During the memory management, we can use the techniques paging and segmentation to avoid internal and external fragmentation for the proper utilization of a memory. And another concept is the virtual memory, which says that if you want to execute a process which needs some more space for its execution, then the physical memory available to it can be executed by using this technique, that if it is present in the backing storage, then it will be bring to the one of the whole of the physical memory, which is a freed first, and make it available for A. In this way, the memory management can be done by using the operating system. So in this lecture, I have discussed only the two main functions of operating system, that is process management and the memory management. Since the time limit is there, so rest of the functions will be discussed in my later lectures. Thank you. Thank you.